In Concept G, we're going to be looking at amines and amides. These are functional groups that involve nitrogen. So an amine is a hydrocarbon in which one or more hydrogen atoms are replaced by an amino group, or what we're going to mostly be using is an NH2. And you're going to see that the suffix of these various names are going to include amine. Now, most of the ones, if not all, we're going to have our amino group be a branch off of a parent, chain, like a methyl branch. We're going to number the carbons within the parent chain, name it, and replace the E at the end of the name with amine. We will need to show a number to show where along that chain we have the group. Now, sometimes you can have an amino group that's buried within the carbon chain, and it's going to look very similar to an ether. You're going to name it exactly the same way you would with an ether, naming each alkyl branch, or each carbon branch, except we're going to substitute the word amine instead of ether. Now, I do want to show you this, it would be an example. We have our amino group buried within a carbon chain, so we have two separate carbon chains around it. We would simply name the carbon chain to the left and to the right, and then use amine, just like we would with ethers. This is pretty rare for us to see in our level of content, so we're going to mostly focus on the first scenario that I gave you, but I do want you to at least see one example of that. So here we have an amine, we have a nitrogen here, we have the one carbon attached to it, and then what we're mostly going to see is when we have hydrogen simply attached off of the other bonds with nitrogen. So here we have one carbon, so we're going to start to write methane and then drop the E and simply add amine. Now, because we only have one carbon, no number is necessary. Here we're going to be drawing an amine. We know it's, again, we can see amine here, knowing that we're going to have a nitrogen. So we're going to start with our prefix for the carbons, prop. So we have 3. The amine group is going to be placed on the second carbon. So I'm going to put my NH2 and then fill in the rest of the carbons with hydrogens. Oops, and there should be an additional hydrogen right there. You guys have talked about amino acids in biology, so where does this come from? Well, amino acid is a combination of an organic acid that we talked about in the last concept with an amino group. So you can see that if here we have our primary carbon here, we then have a amino group attached off of that carbon, and then we have the carboxylic group from our organic acid also attached from the same carbon. And that's how those amino acids from last year came about. Alright, we also have an amide. This is when an organic acid is basically replaced with an amino group taking the place of where the hydroxyl group or the OH was. So with this, we're going to be using the ending AMIDE, so amide. And you can see here the big difference between an amine is that we would only have the nitrogen, and amide has the nitrogen and a double bonded oxygen. So here we're going to focus on our carbon chain. Okay, and then here we can see we have our amide group. So we start to write propane, we drop the E, and we add the amide to recognize this group. And you can see in all examples we're going to do, this is going to be at the end of a chain. So for amides, you do not show a number of where it would be. Here we're going to use our prefix but to start our 4-carbon chain, and then we're going to add on our amide, which is the double bonded oxygen and the NH2 group. And then we fill in the rest of our carbons. This carbon, however, should not get any additional hydrogens. And that's it. All right. Last thing I want to kind of point out, we've been working in labs with isomers. The only difference, remember, is that when we talk about isomers, they have the same molecular formula, but they have a different arrangement, structural arrangement of their atoms. So when we actually look and do one of our labs, we're going to be seeing that different molecules that have the same number of carbons and share very similar functional groups will be isomers of each other. So alcohols and ethers both have one oxygen, so those are going to be considered isomers of each other. Organic acids and esters both share a carboxyl group, so that carbon with a double bonded oxygen and a single bonded oxygen, both organic acids and esters have them. And then aldehydes and ketones both share a carbonyl group, where carbon has a double bonded oxygen. Okay, so here's just an example of some of the isomers we're going to be working with. So in our functional group lab, you're going to be taking a look and kind of picking out some different isomers. So consider these different pairings that we just spoke of. And you are all set.